So will it make the field goal, and by what distance? By what distance would you need in order to make the field goal? So we have a delta x equaling 36.0 meters, and then we have the initial equaling 20.0 meters per second. I'll rewrite that, 20.0 meters per second. And then we have a theta angle measure of 37 degrees. So at this point, we need to find the time in the air. So we have delta x equaling Vx initial t. So this means that t will equal delta x divided by V initial cosine of theta. And this is going to give us 36 divided by 20 cosine of 37 degrees. And we are getting that the time is going to be, we can say time equals 2.254 seconds. At this point, we can say that y final equals y initial plus vy initial t plus 1/2 of gt squared. We know that y initial is going to be 0, and so we can say that this is going to be equal to 20 sine of 37 degrees times the time, 2.254, and then this will be plus, g is negative in this case, so it'll be minus 4.9 times the time squared, so 2.254 squared. And we find that y final equals 2.24 meters. Now the goalpost is at 3.05 meters, so unfortunately this is too low. It will not make the goal. The field goal will not be made because the y final isn't at the height of the goalpost. Now, this will be your answer for part A. Now, the question is asking us what exactly is needed, what time is needed in order to, rather, what x distance is needed in order to make the field goal, and we first need to find a time. So we can say y final equals y initial plus vy initial t plus 1/2 of gt squared. Now, we know that, again, y initial is going to be 0, so we can say y final equaling the height of the goalpost. This would be 20 sine of 37 degrees times time, and then minus 4.9 t squared. This is a quadratic equation, as you can see, so you can simply use your solve function on a TI-84, TI-85, TI-89 in order to solve for t, and t is going to equal 0.2868 seconds and 2.1073 seconds. Now here, we need to realize that both of these times are valid. So when we find delta x, the horizontal displacement needed in order to make the goal, we need to use both of these. So we'll say delta x1, or we'll say delta x1, delta x2. And this will give us Vx initial t1, and then this will be Vx initial t2. And this will give us 20 cosine of 37 degrees times 0.2868, and then this will be 20 cosine of 37 degrees of times 2.1703. This is going to equal 4.58 meters, and this will equal 34.66 meters. So essentially, in order to make the goalpost, you need to be between these ranges, delta x, and then less than or equal to 34.66 meters. This would be the second answer. That is the end of the solution. Thank you for watching.